this is Paul Edwards with Denmark Company. We're providing today a opportunity for continuing education in the use of an Olas Ti safe changing of the activation mixing chamber. Paul Edwards, Denmark Company, is a chemical provider. The product is XG940 and Keeper Pro, which is used in the red meat for further food processing. And in this training video, we're going to demonstrate the safe removal of a mixing chamber of an Olas unit that has been in operation for several years now. On many previous continuing education opportunities, we discussed that the mixing chamber of the Olas Ti can become in a state of usage where you're not able to get a good visual of the mixing chamber itself. As you know, the design has a tube within a tube configuration, and the mixing chamber here that we're going to activation chamber, and it's been called many things. I call it a mixing chamber of the ingredients, but it is really termed in the owner's manual as an activation chamber. But as you can see, it has become opaque, no longer a clear tube where you could actually see through it. When you're going to take an existing plant and replace the activation or mixing chamber, the first thing you want to do is determine how you do it safely. Well, the first thing you want to do it safely, of course, is make sure that you have a way of monitoring your chlorine dioxide to air concentrations, because you may be dealing with some very strong odors of chlorine dioxide. You also want to make sure that you have the ability to purge the center cell. The purging of the center cell is done with the purging line. And I'm going to focus in on that. The purging line is that one right there with the blue handle on the cock valve. That is your purging line. It will purge the solution in the center tube, and as you can see, that does need some service on it as well. There's evidence that the check valves are starting to fail, and so we will be changing those as well. And that purging of the center tube will allow you to get all the activated chlorine dioxide out of the center chamber of the activation chamber and into a line that comes out, and that line that comes out is now has a tubing connected to it that takes that solution on directly to a drain. As you can see there, going down into the drain. And we'll find that drain here in just a second. Where's that drain? There's the drain. Okay, so it's going down into the drain. We'll remove those parts there, but as you can see, it is going down into the drain. That's the ideal method of purging that line, is going directly into the drain. So we'll go and scan back to where we're at on that line. Pardon the movement, but we wanted to demonstrate that for you, okay? Anytime you're going to work with raw materials or any kind of chemistries that are corrosive material in nature, you want to make sure you wear your gloves. So you have to have your latex gloves, and you want to have your safety glasses. Got your safety glasses. And we also have to measure the air quality, the ToxiRate 2 monitor. And as you can see right now, the readings are 0.000. 0.000. We want to keep that if it's possible. It looks like it popped up to 1.01. Okay, so I'm going to lay that down, and we're going to begin the purging process. So the first thing you want to do on purging is you want to make sure that your valve going to the drain is open. So I'm going to go on and do that right now. And then what you want to do is you want to make sure that your line there, your purge line, is turned on. So we're going to turn that on. And what that purge line does, it starts to force your solution out of the center tube, okay? So that purge line is starting to force the solution out of the center tube. And I'm gonna, you can go on and creep it up, okay? You can turn this valve slowly and allow that solution to run through the bottom here, and it's purging the line here and also the center tube. Another thing that I'm doing here is I am going on and I am running water through my take-up line. I have take-up lines here that are running solution through them. These would normally be sodium chloride or acid. I have these lines running directly into water. There's a 5-gallon pail that's filled with water. And so what I'm doing is I'm running water through this line. All of this is going to lead to removal of any raw materials of sodium chloride or chlorine dioxide. And that's what you want to do. Remember, we're considering the safety factors involved here on this. And this is the reason why we would do that. Okay, there is I would say that we can suspect that there may be some damage to the Olas pump, and that's something that will be reviewed at a different time. But the yellowing of this tube right here is an indication that activated sodium chloride may have moved back into the block and affected the O-rings and the stem, the valve stem that goes right in here to make the adjustment. So we'll make a recommendation that the actual pump gets replaced later on and rebuilt, okay? So that's something we're gonna do later on, but right now what we have been doing is purging the center line, okay, the center mixing chamber with water, 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 and water. So we're using water throughout this process, and all we're driving into our tubing down here is water. So we're clearing out this whole line, as you can see, and it's coming through the top of the chamber, and it's coming out through the top of the chamber here, and it's going down to the drain. And this whole time that we've been doing this, we have not seen this Toxi-Ray 2 change from that point 0.000. So I'm gonna tell you that right now, the fact that we're draining into the drain directly and we're not dumping this into a bucket is the reason why that's not occurring, okay? Now if I go to the drain, which is seeing the chlorine dioxide as well as the water, if I go into the drain now, where the high amounts of concentration of this ingredient is going down, I can put my Toxi-Ray into the drain, and I can see what's occurring down here, how the levels are down here, and I would say that the amount of water purge that's going through the line has reduced that load significantly. Right now, coming off of that water line, I'm measuring a 0.01, 0.02. That's a good indication that we're adequately diluting the sodium chloride, chlorine dioxide mixture there. We're adequately diluting that so that those levels are very low. So I'm going to quit now the recording. When I come back to the recording, you will see a new mix chamber installed and a couple other components installed. Hopefully that'll all go over real well. Thank you very much for your time. Okay, this is Paul Edwards with Danmark Company. We're back again discussing the removal of the mixing chamber or the activation chamber of the Olas Ti. and we're going to be shooting blocks of information. So pardon the on and off that occurs, or the changing from filming to filming, because I am going to be doing editing at my office on this material. So I want you to know that. What I want you to notice here is I have the mixing chamber here, and I've taken it out at an angle, okay? I unscrewed it from the top here, okay? When you're changing the mixing or activation chamber, you should be able to twist it from its original position. You should be able to twist it from its original position and then pull it out. Okay, so it was originally up and down like this, but once I disconnected it, I was able to move it out and then unscrew it to pull it off. Okay, and that's the best way to take the activation chamber off. Once you've disassembled this portion from the pump, okay, and once you've disconnected the connectors of the tubings right here. Once you've disconnected all of this, okay, the sodium chloride, the acid, and once you've disconnected all of these components, then you're able to go on and disconnect the entire activation chamber. I also disconnected right here at the sodium chloride total inlet line up here that goes into the top, okay? So I wanted to demonstrate how easy that can be to pull this off, that you just angle it up once you disconnect it from the holding clips. Once you've disconnected the holding clips here, angle it straight up and then unscrew it, and that should cover your need when removing this. Okay, so I hope that helps explain that for you, and I will be back with you in just a moment. Okay, we're coming to the end of our rebuilding process. We have now mounted the activation chamber. It's still at an angle to the relationship of the cabinet, and what you can find is that if you do unscrew it from the top like this and you go to screw it back in, you can also change out all your check valves and all of your fittings and your tubings, everything that's going to require some service. You can go on and do that from this angle as well. As you can see, I screwed that back in place. I've replaced the check valves on it. So we're doing a whole lot better now, and we're going to go on and continue to work on making a more efficient unit. But I'm also going to take the time to talk a little bit about degradation. The tubing that was connected to this is the sodium chloride line. The check valve had failed to it, and so it allowed the activated solution chlorine dioxide to infiltrate the actual block. That's the what I call the manifold, or the block that sits below the Olas pump, and that as you can see, that yellowing, that's an indication that we have had chlorine dioxide seep all the way into that. When that occurs, once again, this is a great opportunity to learn, so we're going to learn. When that occurs, there's a portion of the unit, the lower end of the pump system. I'm going to show you right here. That lower end that I'm pointing to is adjusted to, or is working in conjunction with that metering or adjustment setting. So, you know, I want you to notice that isolated contamination is working throughout that whole block of that pump, and this is where we start to see the performance of the pump become deteriorated because of that. So we've got 1, 2, 3. It's the middle adjustment assembly there that there's evidence that there's some contamination that got in there and will be affecting it. So when we get this pump rebuilt, we can understand how costly it may or may not be when that concentration seeps back into that. So that's a very good learning opportunity. We're going to finish assembling this unit. We're going to start it up, and then we're going to show you the safe startup of this unit. Okay. We're back. This is Paul Edwards with Danmark Company. We've assembled the brand new activation chamber, and I'd like to draw your attention. As you can see, there is a tube within a tube. You couldn't see it before, but it is, you can see it now. And that's what I'm talking about, having the ability to determine what your concentration is of your solution strictly by sight. Okay, so you can actually see what the chemistry looks like. So now that you've got your assembled unit in place, okay, you've replaced the activation chamber with the new one, and you're fixing to start it up, okay, what are the key things to remember here? Well, first of all, a key thing to remember is that key thing to remember is that when you're starting with a brand new setup, okay, and you have the brand new assembly of the solution in place, and you have that visualization right now that you're looking for is the appearance of the sight tube here. Then the next thing you want to do is start it off safely, okay? These lines that used to be the chemical lines are of major consideration. Looks like I'm running out of tape. I gotta start with a new CD. So hang in there with me. Going to a additional DVD to do this work. Okay, so hold for just a second. Okay, we're back. Had to replace the battery. Technical difficulties. We've installed the brand new activation or mix chamber. And now we're ready for state startup of the Olas Ti. In order to create a safe startup of the Olas Ti, you want to go on and make sure that you have water running through all your chemical lines, not chemistry. Okay, in all startups, you want to run water through all your lines until the activation chamber is filled with water. If there's any kind of unexpected events, guess what? You don't have any chemistry in the activation chamber. If you have chemistry running into the activation chamber, not water, now guess what? You've got to take the chemistry out in order to repair anything with the activation chamber that's occurring. So keep that in mind, that it's very important to work with water. Even in your metering lines, even in your center lines, everything should be used with water, okay? So now what we're going to do is we're going to get things running again. We're going to turn on our water line. We're going to turn on our purge line. The purge line has to be used to fill up the mix chamber in the middle. The activation chamber in the middle, the purge line must be on. This is your purge line. It must be on in order to fill that center tube with water, okay? Yes, your pump's going to be drawing in water, but it's going to be very small amounts of it. What we want to do is we want to fill that up quickly. So we start by turning on our water knob. Turn it on slowly, okay? There's no reason to go into your Olas system with full pressure and full volume. Just barely turn it on where you can see the pump slightly moving. Allow the water to fill up. Now, if you'll look over, the chamber quickly filled up. We're talking about the center chamber filled up and the outside chamber filled up with water. Both of them filled up quickly. And the reason that occurred is because we had our purge valve turned on and we had our outside water coming through. So both the purge valve and outside water lets you draw water through there, and your pumps right now are looking at water too. This is a great opportunity that you're running water to look for leaks, okay? Generally speaking, you should only have to hand tighten nuts. You should only have to hand tighten. But there are some times where you do need to use tools to tighten up leaks. So we want you to do that, okay? Remember, gloves for protection. Even though you're messing with water, use your gloves. Good safety habit. And safety glasses, okay? Safety glasses as well. Okay, I'm going to tighten things up, but we're done, folks. What I will do is I'll take these lines, these chemical lines here in the bottom, and I'll move my camera down so we can see that. Yeah. Maybe it don't. There we go. I'm gonna move all these chemical lines right here that are running water in them. I'm gonna go on and put them into their designated chemistry, which these two will be. These two right here, these lines right here is sodium chloride, and the last one over here is acid, and we'll put those back in there after I've tightened things up, addressed my leaks, and then we will run it. But this is it. This is a safe startup of the Olas Ti. It's a safe replacement of the activation chamber. You know, if it wasn't for independent processors and corporate processors that allowed Denmark Company to come into their facilities and do these kind of safety videos on proper replacement of parts on the Olas Ti, if we did not have that cooperation, we wouldn't have this valuable training aid. So I want to thank all the independent processors out there, named and unnamed, for letting us do this at their plant, because it really helps the industry out a great deal. If you have any other questions, please call Denmark Company at 817-822-5767, 817-822-5767. All DVD, training DVDs are available to our customers free of charge. And you can visit our website at www.danmarco.net. Once again, our website is www.danmarco.net. That's DANMARCO.net. Visit us, send us an email, call us up. If you have any questions, we can email you information, as well as we can go on and send you a DVD in the mail. Thank you very much and have a good day. I'm back. This is Paul. One of the things I wanted you all to notice is when the acid and the sodium chloride starts to mix, I want you to notice how that color changes. This is just an add-on feature. We've got this acid and sodium chloride that's being pulled in to the mixing chamber, and as that acid and sodium chloride enters the mixing chamber, it starts to form chlorine dioxide, and that's a very unique experience. So I kind of want to go on and let you see this occurrence. Moving my knob setting down of my acid, and I've got my sodium chloride where I want it. I'm bringing my acid down, but as the sodium chloride starts to form chlorine dioxide, you're going to see a very obvious color change occur in that mixed chamber. And I want to catch that on video for you guys, because I think that's a great opportunity to see that and learn. And you just watch really closely there as that starts to change. Look at the flashlight. Okay. You see that color? It looks like either the sun setting or the sunrise, however you want to describe that. But you can see that distinct color change occurring. Okay, see that color change, folks? I'm going to use this flashlight to demonstrate that. You could not have seen that color change with the prying mixing tube. You see that? You can see that there's a distinct line there. If I put this flashlight behind it, sometimes you can actually see the effect as well. And that is dark red and then clear. And you're seeing that change before your eyes. That's a very neat effect. And that is just the chlorine dioxide being converted from acid and sodium chloride, which originally is a clear color. It looks like water. You look at sodium chloride, it looks like water, okay? But with it mixing in the activation chamber, and doing a startup, you can actually see that color change. And I just wanted to add this on to the training. Whenever I see these opportunities, I take advantage of them. So thank you once again for your attention, and we appreciate your business. And thank you. Be safe first, folks. We don't want anybody getting hurt out there.